Hello, everyone. This is the fourth and final video of the AWS Machine Learning Specialty Exam Prep course, where we'll be talking about the final section of the exam, which is about ML implementation and operation, and which weighs 20% of the total exam content. We'll be following the same strategy as in the previous videos, where we'll be discussing the content, and then we'll end up with sample questions which help us test what we learned. If we start giving a brief overview about the content of the section, this section aims at covering the concepts and best practices for managing, deploying, and monitoring machine learning models in production environments. If we go into the main topics that will be covered in this section, it will be mainly about Docker containers. We're going to talk about SageMaker and VPC, which we already did touch on it in the first video of the course. We're going to talk about SageMaker logging and monitoring, how to choose the right instance, what's auto-scaling, some of the AWS SageMaker features like Neo and IoT Greengrass. We're going to discuss inference pipelines, serverless inference, production variants, model registry, and we'll have a section to talk about the high-level AI services which are available in SageMaker, such as extract, transcribe, personalize, comprehend, poly, lex, forecast, and translate. And as I said earlier, we're going to end up with some sample questions. To start, talking about Docker. So SageMaker provides pre-built Docker images for its built-in algorithms. So whatever algorithm we end up choosing from AWS SageMaker, like linear learner, XGBoost, sequence to sequence, these models or algorithms, they have their own pre-built Docker images that we can load it from ECR, as we discussed in the SageMaker architecture in the previous video. And these Docker images, we can load it from there, and the supported deep learning frameworks, which we can use it for training and inference. So using these Docker containers, you can train your machine learning algorithms and deploy models quickly and reliably at any scale. So we can load the training code image or the inference code image from the Elastic Container Registry, and we simply train our model and we bring it to production using Docker. The next topic is about SageMaker and VPC, which we did talk about in the first video, and VPC stands for the Virtual Private Cloud. And these, it's good to know that SageMaker training jobs runs in VPC, and we have what we call the VPC endpoints, S3 VPC endpoints, with Amazon SageMaker is used to ensure data security and privacy, and to make sure that data is not going through the public internet, and there is a private connection between the VPC and the SageMaker services, or S3. If we want to see the logs and monitor and alarm the invocation and the latency of endpoints, we can use CloudWatch for that. So CloudWatch helps us to see logs and to monitor and alarm the invocation and latency of endpoints, and to make sure that everything is running smoothly and no errors are being captured. Whereas CloudTrail, it helps us to record actions from users, roles, and services within SageMaker. So if we sum it up, CloudWatch can log, monitor, and alarms on invocations and latency of endpoints, whereas CloudTrail helps us to record actions from users, roles, and services within SageMaker. We also did talk about that on the previous video. When we are creating our notebook instance in SageMaker, we have to choose the proper and correct instance type. And in general, deep learning algorithms requires GPU instances, so we have to choose P2 or P3 for training. Whereas if we want to choose an instance type for inference, inference is usually less demanding, so we can use compute instances such as C4 or C5. So we need to know that for deep learning algorithms, also it's preferable to use GPU. P2 and P3 are good examples. And for inference, we can choose less demanding instance types. And for that, we can go for compute instances like C4 or C5. Automatic scaling. Automatic scaling, it's a capability which helps us to dynamically adjust the number of instances provisioned for a model in response to changes in the workload. So if we have more workload, then auto scaling will bring more instances online. Whereas if we have less workload or the workload decreases, auto scaling removes unnecessary instances. So that's what help us to avoid paying for provisioned instances that are not being used. It's like cost effectiveness technique that helps us to remove unnecessary instances that are not being utilized efficiently. Inference pipeline. Inference pipeline, we can think of it as a linear sequence of 2 to 15 containers that would combine different stages of ML cycles, such as data processing, model training, predictions, post-processing. And inference pipeline, it helps us to perform real-time inference and batch inference as well, or batch transforms. So whatever deployment option we choose, we can aim to use inference pipeline for that. The next topic is going to be about SageMaker Neo, and Amazon SageMaker Neo, it uses a technology called model optimization, where it optimizes a trained machine learning or deep learning model for us and helps us to be deployed for specific target devices and platforms. That's in a nutshell. What does SageMaker Neo do? It produces a compiled and highly efficient version of the model that can be deployed on edge devices with reduced memory and computation requirements while maintaining accuracy. So if we have like a big trained deep learning model and we want to bring it to edge devices, we can use SageMaker Neo to reduce the memory and the computational requirements of this model without like touching or like reducing accuracy, and then we take it to the edge device. So it optimizes the model for deployment in edge devices. Whereas AWS IoT Greengrass, it extends cloud capabilities to edge devices, allowing them to perform computing tasks locally and securely, even if they are not connected to the cloud. So if we want to bring a model to the edge device, first of all, we need to think of SageMaker Neo to do the model optimization. And in order to make the model to run on the edge device without the need to connect to the cloud, then we have to think of AWS IoT Greengrass. This is where like IoT Greengrass and AWS SageMaker Neo can work together. So AWS IoT Greengrass can ensure getting the model to an actual device without the need to connect it to the cloud. If we combine SageMaker Neo and IoT Greengrass together, Neo can do the model optimization. So Neo can compile and optimize the model. And IoT Greengrass can get the model deployed to the device you want without the need to get connected to the cloud. The other feature that we cannot talk about is Amazon SageMaker's serverless inference, which is purpose-built inference option that makes it easy for you to deploy and scale machine learning models. So serverless inference is ideal for workloads which have ideal periods, where you can create serverless endpoints, automatically launch compute resources, and scale them in and out depending on the traffic. So if you have more traffic, you will get more compute resources, and if you have less traffic, you will have less compute resources. And this is also avoid us paying more costs for compute resources that are not being utilized efficiently. So Amazon SageMaker Serverless Inference, it helped us eliminate the need to choose instance types or to manage scaling policies, because it will manage these policies for us on our behalf, and it will increase or decrease these compute resources based on the amount of traffic that we receive on the model. Production variants is another topic which referred to the different deployment configurations or instances that host your trained machine learning models for serving real-time predictions. So if you are bringing a machine learning model to be deployed for real time with like interacting with end users, we can think of creating multiple variants of this model with different instance types to handle varying workloads and serve predictions at scale. Also, prediction variants could be used in case of doing A/B testing, where we need like to bring two versions of models for people. Then in this case, we can use multiple variants, or like we can use production variants to have different instance types to handle varying workloads depending on the business strategies on launching and deploying the ML model. Horwood is distributed deep learning training framework, which can be used for TensorFlow, Keras, PyTorch, and Apache MXNet. And it's available on AWS SageMaker. It's good to know that Horwood was originally developed by Uber to make distributed deep learning fast and easy to use. The next topic we're going to talk about is model registry, and model registry helps us to track model versions. So if we are like refining and developing the model, and we'll have different model versions, model registry can help us to track these model versions. It can group models by use case, and it helps to manage the approval status of a model by ML engineers based on the performance matrix. It helps us to deploy models to production and to automate model deployment with CI/CD. The next section that we're going to cover is the high-level AWS AI ML services. And we're going to start talking about Amazon TextRect. And Amazon TextRect is a fully managed machine learning services that automatically extracts printed text, handwriting, and other data from scanned documents, such as financial reports, medical records, tax reforms, and university application forms. And it goes beyond the simple optical character recognition that can be done by Python. So it identifies, understands, and extracts data from forms and tables as well. So if the question entails something related to extracting printed text from PDFs or understanding and extracting text from forms and tables, then we have to think of Amazon TextRect as a potential solution for that. The next service is Amazon Comprehend, and Amazon Comprehend uses machine learning to help uncover the insights and relationships in unstructured data, which is text data, such as input social media, emails, web pages, documents, transcripts. And for medical records particularly, we can use Comprehend Medical. So Comprehend Medical is like a special version of Amazon Comprehend, which deals with medical records. So Amazon Comprehend extracts key phrases, entities, sentiment, language, syntax. Within Amazon Comprehend, you can train your own custom model on your own data. If the question entails something related to studying sentiment, document classification, then we have to think of Amazon Comprehend as potential AI solution for this. The next service is Amazon Translate, and Amazon Translate, from its name, it does text translation service, which uses state-of-the-art deep learning to provide high-quality translations to customers without the need of any deep learning knowledge. It's used to translate text from various languages. It could be Spanish, Arabic, Greek, German, French, etc. Again, if the question entails translating, and they're asking for the best AI for the available AWS AI solution, then we have to think of Amazon Translate as a good solution for this. The next service is Amazon Transcribe, and Amazon Transcribe, it simply transcribes voice data. So we give it voice data in terms of MP3 files, for example, and it helps transcribing or transforming this audio to text without any prior machine learning knowledge. So what's unique about all of these services we're talking about is that the one who's using these services, they don't need to have like knowledge about deep learning frameworks or how to train or deploy. it's giving you like a ready service, and you just give it your data, connect to the API, and it does the work for you. Amazon Transcribe, it also includes speaker identification. So like if we're talking on like in call center, it identifies agent versus customer. It has automatic language identification, channel distribution, PII identification. PII stands for personal information identification, and you can include customer vocabularies as well. And within Amazon Transcribe, you also have Amazon Transcribe Medical, which is an ASR service that enables you to transcribe medical audio such as patient to physician conversations. So far, we did say that Comprehend and now Transcribe, they both have special versions which handles like medical data. Amazon Transcribe Medical handles medical data, and Amazon Comprehend Medical also handles like medical data as well. The next service we're going to talk about is Amazon Poly, and Amazon Poly, it converts text to speech. Transcribe converts audio to text, and Poly converts text to speech or text to audio. The user provides some text either as plain text or using a syntax called SSML, and then Poly reads this syntax and generates a lifelike voice using one of the pre-built voices. We can use English, Arabic, Spanish, or Russian in order to transform the text to speech. The next service we're going to talk about is Amazon Recognition, and Amazon Recognition is an AI service which is used to implement image or video analysis workflows into their applications. Some of the business use cases for Amazon Recognition could be image classification, object detection, facial recognition, celebrity recognition, people paths, or to simply detect text and image. Amazon Forecast is another fully managed service within SageMaker, which is used to deliver high accurate forecast, also without the need of any machine learning knowledge. The forecast service, it uses machine learning to combine time series data with additional variables to build forecast. It also implements AutoML, so you give it the data and it will choose the best model for your available time series. These models could be ARIMA, DeepAR, ETS, MPTS, CNN, and I would advise you to go to the Amazon Forecast documentation and try to understand the differences between these models. Some of the use cases for Amazon Forecast could be retail and inventory forecasting, workforce planning, or travel demand forecasting. The next topic or AI service we're going to cover also Amazon Lex, and Amazon Lex is used to build and deploy the chat interface and respond to user intent. So it's used to build chatbots, in other words. In this context, we can think of an intent is an action you want the bot to perform, and an utterance is what the user actually asks for. And a slot is the set of parameters. So in order to build Amazon Lex, or in order to build chatbot, you need to think of your intent, your utterance, and your slot. If you take an example, let's say you are building a chatbot for pizza delivery, and if you are ordering a pizza using this chat box, the utterance could be, I would like a pizza. The intent could be order pizza, and the slots can be size. And the slots value could be either small, medium, large. So Amazon Lex could be used to build chatbots, and you need to know what's an intent, what's an utterance, and what's a slot in the context of building a chatbot using Amazon Lex. Amazon Personalize. Amazon Personalize is also another AI service which allows businesses to rapidly develop personalized recommendation systems to provide a better customer experience to their end customers. There are two available APIs within Amazon Personalized. First one is called Get Recommendations, which get recommended products or content for users, or Get Personalized Ranking, which rank a list of items to be provided to customers. So Personalized is used for building recommendation systems, and there are two APIs there: Get Recommendations or Get Personalized Ranking. This takes us to the end of the content of the MLOps section, and now we will start tackling some of the sample questions. But before that, as I said in the previous videos, I would advise you to take the explanation of this content like as first essential step for you, but you need to take note of each of the topics we discussed, and you need to go for the AWS documentation and read more about it, especially when we talked about the AI services. Make sure to know what does each AI service do and when to use it and how to build it. I mean, how to code the API for this AI service and start using it. And also like go into some sample codes for that. And also you need to know how to do monitoring within SageMaker, what are the best techniques in order to reduce cost while bringing models to production, such as using auto-scaling or serverless inference. You need to know all of these topics, and you need to make sure you are confident to answer any question which would come through your way in the exam. If we start with the sample questions, first of all, we need to read the question, look for keywords, and then think of a potential solution. Question 1, they are telling us you work for an insurance firm trying to automate insurance claims processing. As a first step, you want to perform optical character recognition and extract forms and tables from PDF documents. What AWS service would you use to get started with this use case with minimal effort and quick outcomes? So we should think of automate insurance claims, optical character recognition, and extracting forms and tables. And it's going to be with minimal effort and quick outcomes. So we don't have to build a solution from scratch. And for optical character recognition or extracting forms and tables from PDF documents, we can think of Amazon TextRect. And if we look on the solutions, we have AWS SageMaker, which entails developing a solution from scratch because we need to train a deep learning model for that. Amazon TextRect is option B, Amazon Candra is option C, and Amazon Comprehend is option D. And definitely we have to choose Amazon TextRect. So the correct answer for this question would be option B. Question 2, they are telling us an asset management firm would like to build a chatbot-based solution to automate advice given to their clients by their financial advisors. They are concerned due to their diverse global client base that chatbot will need to translate incoming text into English before the advice can be rendered. What services would you use to build this solution in a fast and efficient manner? Keywords here, chatbot. But they are concerned about diverse global clients and need to translate as well. So we need to build a chatbot with translation. To build chatbot, we can think of Lex, Amazon Lex, and to do the translation, we can think of Amazon Translate. And if we look on the solution, Lex Translate is option A, and this is the correct answer. Question 3, they are telling us which AWS service would you use to view performance matrix from your SageMaker endpoint and set alarms and appropriate thresholds to auto-scale the SageMaker endpoint if they are surpassed. We did discuss that. So the keywords here, performance matrix and set alarms. And this is what Amazon CloudWatch do. So Amazon CloudWatch helps you to monitor the latency of endpoints and helps you to set alarms and thresholds to auto-scale a given SageMaker endpoint based on workload or traffic. And we see Amazon CloudWatch is option B, and it's the correct one. Question 4, which AWS service would use to log API calls made by users to Amazon SageMaker in their ML environments for audit purposes? We did also discuss about that, and for that we should use Amazon AWS CloudTrail. So AWS CloudTrail helps you to log or monitor the actions made by users. And Amazon CloudWatch, it helps you to monitor the latency of endpoints and auto-scale if there is a high incoming demand on traffic. So for this question, for logging API calls made by users, we have to choose AWS CloudTrail. So option D is the correct one. Question 5, they are telling us you are a machine learning specialist at a government agency that processes citizen applications for government documents. Your team is responsible to determine fraudulent activity in the document application process. You are preparing a subset of your agency data for model training in order to use your data in your SageMaker notebook. You have stored data in S3, and the data contains personally identifiable information, which is like high security data. In order to maintain the high quality of security, the data must be accessible only from your VPC, and it cannot traverse the public internet. Which option best meets your security requirements? So this is about networking and security. Keywords to look here, keywords to look into here. Data is stored in S3, PII information, and the data must be accessible within your VPC, and it cannot traverse the public internet. So in this case, we have to think of VPC endpoints, which helps us to build like a private connection between our VPC and the AWS services without going through the internet. If we look into the options, option A, use VPC endpoint and leverage security group restrict access to VPC endpoint. Use a VPC endpoint and leverage a network access control list to only allow traffic between the VPC and S3. Use a VPC endpoint and leverage a bucket access policy to allow access to S3 bucket from the VPC endpoint. Or option D, use a VPC endpoint and leverage a bucket access policy to deny access to S3 bucket from resources other than VPC endpoint and the VP. So for sure, we want VPC endpoint. And we want something to do with S3 because the data is stored in S3, and because they are telling us the data must be accessible only from within your VPC, then we have to think of a policy which denies access to S3 other than the VPC endpoint and the VP. So option D would be correct, which helps us to build the VPC or use VPC, which leverage a bucket access policy to deny access to S3 from sources other than the VPC and the VP. If we look at option C, it's telling us use the VPC endpoint and leverage access to allow access to S3. We don't want to allow access for other users or other VPCs. We should only this VP should be able to access the S3. So we have to choose option D as the most correct answer in this scenario. The last question is question 6. They are telling us your machine learning team is responsible for processing video clips posted to your company's Twitter social media account to understand the sentiment of the video clips. Your team takes these video clips and labels them with appropriate sentiments so that your marketing department can use them in their advertising campaigns. You will now need to translate video clips as part of your sentiment labeling process. I think I missed this line. So you are now expanding into Spanish and Portuguese-speaking regions of the world, and you need to translate video clips audio as part of your sentiment labeling process. What AWS services or SageMaker built-in algorithms allow your team to label the foreign language video clips in the most efficient manners? Keywords to look into here: processing video clips, so Amazon Transcribe, then understanding the sentiment of understanding the sentiment of the transcribed audio, so we can think of comprehend, and because we are expanding and we want to translate to other languages, we can think of translate. And if we look on the solutions, transcribe, comprehend, translate is option A, and this is the most correct answer because it will help us to process and transcribe the video clips and transform audio to text. And then after transforming the audio to text, we can use the text of this social media content in order to determine the sentiment. And then because we're expanding into different regions and we're thinking of different languages, you can translate this audio into other languages using translate. This takes us to the end of this section where we did discuss the content of the fourth section of the exam, which is MLOps, and we did solve some questions. I would advise you to review these questions and to try to solve it by yourself, and to further take the content that we discuss, read more about it, and make sure you grasp all the content with confidence. I hope you find it useful. Good luck on your exam preparation, and feel free to get in touch for any questions or feedback. Thank you for watching, and goodbye.